In thermodynamics, the term exothermic process describes a process or reaction that releases energy from the system, usually in the form of heat, but also in a form of light, electricity, or sound. Its etymology stems from the Greek prefix epsilon chi omega and the Greek word theta epsilon rho mu iota kappa omicron sigma. The term exothermic was first coined by Marcel and Berthelot. The opposite of an exothermic process is an endothermic process, one that absorbs energy in the form of heat. The concept is frequently applied in the physical sciences to chemical reactions, whereas in chemical bond energy that will be converted to thermal energy. Exothermic describe two types of chemical reactions or systems found in nature, as follows. Simply stated, after an exothermic reaction, more energy has been released to the surroundings than was absorbed to initiate and maintain the reaction. An example would be the burning of a candle, wherein the sum of calories produced by combustion itself, which with oxygen have become hot CO2 and water vapor, exceeds the number of calories absorbed initially in lighting the flame and in the flame maintaining itself, outstripped by the energy produced in breaking carbon-hydrogen bonds and combination of oxygen with the resulting carbon and hydrogen. On the other hand, in an endothermic reaction or system, energy is taken from the surroundings in the course of the reaction. An example of an endothermic reaction is a first-aid cold pack, in which the reaction of two chemicals, or dissolving of one in another, requires calories from the surroundings, and the reaction cools the pouch and surroundings by absorbing heat from them. An endothermic system is seen in the production of wood. Trees absorb radiant energy from the sun, use it in endothermic reactions such as taking apart CO2 and H2O and combining the carbon and hydrogen generated to produce cellulose and other organic chemicals. These products, in the form of wood, say, may later be burned in a fireplace, exothermically, producing CO2 and water, and releasing energy in the form of heat and light to their surroundings, e.g., to a home's interior and chimney gases. Overview. Exothermic refers to a transformation in which a system releases energy to the surroundings, expressed by Q less than 0. When the transformation occurs at constant pressure, one has for the enthalpy clarification needed increment H less than 0, and constant volume, one has for the internal energy increment U less than 0. In an adiabatic system, an exothermic process results in an increase in temperature of the system. In exothermic chemical reactions, the heat that is released by the reaction takes the form of electromagnetic energy. The transition of electrons from one quantum energy level to another causes light to be released. This light is equivalent in energy to the stabilization energy of the energy for the chemical reaction, i.e., the bond energy. This light that is released can be absorbed by other molecules in solution to give rise to molecular vibrations or rotations, which gives rise to the classical understanding of heat. In contrast, when endothermic reactions occur, energy is absorbed to place an electron in a higher energy state, such that the electron can associate with another atom to form a chemical complex. Net energy is absorbed by an endothermic reaction. In an exothermic reaction, the energy needed to start the reaction is less than the energy that is subsequently released, so there is a net release of energy. This is the physical understanding of exothermic and endothermic reactions. Examples. Some examples of exothermic processes are combustion of fuels such as wood, coal and oil, petroleum; thermite reaction, reaction of alkali metals and other highly electropositive metals with water; condensation of rain from water vapor; mixing water and strong acids or strong bases; mixing acids and bases; dehydration of carbohydrates by sulfuric acid; the setting of cement in concrete; some polymerization reactions such as the setting of epoxy resin; reaction of most metals with halogens or oxygen; nuclear fusion in hydrogen bombs and in stellar cores; nuclear fission of heavy elements; implications for chemical reactions. Chemical exothermic reactions are generally more spontaneous than their counterparts, endothermic reactions. In a thermochemical reaction that is exothermic, the heat may be listed among the products of the reaction. Contrast between thermodynamic and biological terminology. Because of historical accident, students encounter a source of possible confusion between the terminology of physics and biology. Whereas the thermodynamic terms, exothermic and endothermic, respectively refer to processes that give out heat energy and processes that absorb heat energy. In biology, the sense is effectively inverted. The metabolic terms, ectothermic and endothermic, respectively refer to organisms that rely largely on external heat to achieve a full working temperature, and to organisms that produce heat from within as a major factor in controlling their bodily temperature.